thanks everyone for joining today's SPRAY seminar. And today we're delighted to have Dr. Anna Kuczynska Lazewska from Gdansk University of Technology, Poland. Her visit to SPRAY is supported by UNSW Engineering Diversity in Engineering Academic Visitor Funding Scheme. So Anna's research focuses on solar panel recycling for both silicon and cadmium telluride-based panels. And she used cradle-to-cradle life cycle assessment approach to evaluate and improve material recovery. Her research emphasizes on not just recycling, but returning those recovered materials into useful new products rather than relying too much on primary raw materials. And today, she's giving us a seminar entitled A New Perspective on Material Recovery in Photovoltaic Module Recycling Processes. And after her seminar, she's happy to answer questions. So please join me welcome Anna.
Thank you very much, Ron. Before I start, I wanted to acknowledge the traditional owners of the land on which we are meeting today. I pay my respects to the elders, past and present, and the elders from the other communities who may be here today. I will talk today about the new perspective on material recovery in photovoltaics in module recycling processes, but I want to give you a little bit of context and behind the scenes of my research. So today I will be talking a little bit about the backstory. So where I come from and why I'm doing what I'm doing. My research about the new approach that I find that we should introduce into the recycling research, and about the future of my research, and maybe something you also would like to include in your research. So here is a picture of saffrons that grow in the wild in Poland. I have news that they started to bloom this month in Tatry Mountains in Poland. So I wanted to include this Polish spring into Australian autumn. So I was born on 7th of November in 1990 in Gdansk. So this is the same day and month as Maria Skłodowska-Curie, but only 123 years later, and the same city as Daniel Gabriel Fahrenheit, only 304 years later. I think that may be coincidence, but maybe not. I'm from Republic of Poland. The area of Poland is quite small in comparison to Australia because you can fit Poland between Sydney and Melbourne, but in European point of view, it's one of the biggest countries. The population of Poland is bigger than in whole Australia, and the capital city of Poland is Warsaw. So there are some things that, in my opinion, connect me to Australia from the very beginning. So when I was a child, one of my favorite books was Tomek in the Kangaroo Land. And this is the story about the boy who came from Poland, and with his father, he was traveling throughout Australia and catching wild animals to bring them to the zoos in Europe. I don't think that's a quite good approach with the wildlife, but for me, in that story, the most beautiful was they were traveling throughout these different lands, totally different animals, and everything that I was reading in that book made me want to visit Australia one day. The second thing is that I was living at the street named the Kościuszki Street. So this is the same name as the Mount Kościuszko, and it was named about in honor to freedom fighter Tadeusz Kościuszko by the Polish explorer Paweł Edmund Strzelecki. So I think there are some connections between Poland and Australia, and also this is a picture from Gdansk Zoo. We have some wallabies there, so I also always wanted to see them in the wild, and I had this opportunity on Basin Campground near Sydney. And I also love photography. So this is the reason why during my research topics I wanted to connect my passion with the research, and I was studying photoactive materials. And this is why during my first and second degree I was doing research on photocatalysts and photoactive materials. So first I wanted to study the new alternative for titanium dioxide photocatalysts, and I prepared strontium titanide. Then on my second degree I prepared some nanocomposites with 3 different photocatalysts in them, and went for a 3-month internship in Leibniz in Rostock. And during this internship I figured out this is what I want to do, the research and doing some education with young people and bringing the knowledge. This is what I want to do. But you'll ask, okay, but where's recycling? Where's photovoltaics? What she's talking about, photocatalysis, it's not what we came here for. And this is because when I returned from my internship, it came out that my supervisor of my thesis couldn't take any more PhD students at the time. So I started to look for an alternative topic, what I can do. And I came to now my boss, Ewa Klugman-Radziemska, and she told me, okay, I had this great topic for you about synthesizing a new photoactive materials for some solar irradiation measurements, so that would be great. But few days earlier came this guy and he took the topic. So only topic I'm left with is the photovoltaic recycling. And I said, okay, it's not the thing that I wanted to do, but it's still fine. But when I started to look into it, it made more sense. And this is how I ended with my PhD thesis on technologies of recycling and of life waste solar modules of the first and second generation. And all the time I stayed in my alma mater in the Gdansk University of Technology, and this is the place where I'm working right now. And this is reason why is because it's connecting the tradition and the old approach to the academic to the new approach and new technologies, the innovation, and wants to combine them together. Our president of the university even is telling us that he wants to make us the second MIT. I don't know if that would happen, but it's good to try and reach high. So why photovoltaics? Poland in the European map of solar irradiation is not the worst place, but not the best one. In average, we have 1000 watts per meter square, but this is the average. Poland have different seasons, very different from each other, depending on the time of the year we are at. Different landscapes. From the north, we have some dunes, the sea coast. Then in the middle, we have flat areas, mostly with the agricultural areas and the woodlands, the beautiful woodlands. And then on the south, we have the mountain ranges. So the best solar irradiation is really on the south. But there is a lot of flat space to put the photovoltaics in. So how it looks from the photovoltaic point of view in Poland, most of the installations are the micro installations. So people who own their houses, they put their small photovoltaic installations to have their green power. We have few big above 1000 kilowatts electricity generating facilities. The biggest one is in Zwartowo. This is on the Polish coastline, and this is the picture during the building time of this facility. It was the winter time, so you can see the problem here, I think, in this picture. So this means that we don't have a lot of big facilities who are producing a large amount of waste PVs of the same kind. So most of the waste that is produced in Poland are from different manufacturers, different types of PVs, all around. They are the very old ones, the new technologies, depending on the time they were installed and the amount of money that people gathered to install them. So this is why I found out that this is a great topic for me. I want to do it. So I started my research. At first, I learned the life cycle analysis, and with my boss, we started to look into reusing of silicon in the manufacturing process of the PVs. So how we can reuse some silicon in the manufacturing process, so return the material into the process. Then I found out that the delamination is the worst part of the whole recycling of PV modules. Anyone who are dealing with the PV recycling knows what I'm talking about. The lamination, the EVA is made to stay long, don't decompose in any circumstances. So when we want to remove it from the PV, it's the hard job. So I started with the thermal delamination, went into chemical delamination, tried to compare them, and I was working with the thin film modules with CdTe in them. And I found out that the cadmium, not the best, and the environmental impact on the waste modules of the second generation lying in the landfill is even worse than for silicon ones. So I started my research on recovering the cadmium and trying to release the glass to be recycled and to recover the cadmium and the telluride. We didn't manage to do that yet, but we are on our way, hopefully, to do it. But also I applied for the funding to do the life cycle analysis of the cadmium telluride delamination process, because most of the publications were focusing on the composition of the foil or the laminate itself, but didn't include how cadmium inserted in the PV module is influencing the process and how it can change the contents of the emissions that are made during the thermal delamination. So these are the part of the results we gathered. Hopefully they will be published soon, so they will be available for you to read. But the grant is now done and hopefully finalized with the report. Then I tried silver recovery process, because this is one of the most valuable materials in the PVs. So we know how to deal with the aluminum from the frame, what to do with the glass, but how to recover the materials from the cells itself, that's the challenging part. So there is where the hydrometallurgy comes, and I was trying to recover that silver. And then I was trying to find some new ways to recover the silver. I came to certain barrier with getting funds and money for my research. And that was also the time I finished my PhD. I didn't know what to do with myself. Okay, I got employed and started working at the university, but what I will do next? And my colleague told me, you should apply for the funding for the international postdoc somewhere. And when she told me that, I was like, okay. All the time I was doing my research, there was this one person who published all my thoughts before me. Like few months before I wanted to publish something, there was this publication of the same person who did it before me. It was Pablo Diaz, who was the former employee of UNSW. And that was my first thought. Okay, if I cannot compete with that person, maybe I can cooperate with them. So I sent my CV to him, and with my big surprise, I got the response, but not from Pablo, but from Richard Korkish, who's sitting right here. And he told me he wants me to come to UNSW and work with his team, mainly with the Ron Dang sitting on the other side. And I was like, my dream come true. Not only I'm doing the research that I'm really involved into, but also I can visit Australia, what I wanted to do for a very long time. So that was the win-win situation for me. I came to Sydney, and thankful to Ron, I was able to contact with the people who are doing the recycling. So the industry, talk to them and know what they want to do with all of that materials that are in the PVs. And that also helped me to change my perspective. So I wasn't feeling stuck anymore. I knew what I wanted to do. And I started to work with the conductive polymers to recover silver from the solutions after the etching process. So no electrodeposition of silver, no energy used for the silver recovery, only conductive polymers. But you will tell me, okay, but you still need the energy to produce the conductive polymers. Yes, that's true. And the recovery rate wasn't great either. 40% of recovered silver is not much. But when I saw the SEM pictures, I fell in love. These nanoparticles on the surface of the conductive polymers made me think, okay, I cannot simply burn the conductive polymer in a furnace and get pure silver. It's too beautiful to do that. I cannot destroy the samples. I started to think, maybe I can use this composite for something else. So I started to look into the properties of this composite itself, so the conductive polymers and the silver nanoparticles on the surface. And this is where I came to conclusion, okay, maybe we don't have to do the recycling process and go back to the raw materials. Maybe we can design the recycling process so at the end we will get the product, not the raw material, the substrate to any process. So I started to rethink the whole world I was learning before about the PV recycling and getting all the materials from the PVs to the raw form, the silicon, the silver, and so on, and started to thinking about it as a designing process, the synthesis of something new. And we figure out that these nanoparticles are not pure silver. They have the core shell structure of the silver chloride on the inside and the silver on the outside. So that may mean that chloride that was used as a counter ion in the conductive polymers is really inducing the process of formation of these nanoparticles. And maybe using different kinds of counter ions, we will be able to design the shape of the nanoparticles, the size of the nanoparticles, or the distribution. And we started the research in that field. So our main finding is that the nanoparticles may have core shell structure with the silver on the inside and the silver on the outside and the silver chloride on the inside, that there may be the influence of the counter ions of the conductive polymers. And we are looking into that and trying to synthesize new conductive polymers with different counter ions and see what will happen. And also this change of mindset, that maybe the raw material is not the way that we should go for, but maybe we can design some new materials. So what is the future? What will future bring? I started to find out that my hydrometallurgical knowledge that I gained through the years of PV recycling may be useful in the lithium-ion batteries recycling too. And there were a few ideas that came out that not only we can recover some materials from lithium-ion batteries, but they can also be used as the photocatalysts. So that will match my previous experience from the photocatalysis realm of science. And also that maybe we can use some recovered materials from photovoltaics in lithium-ion batteries. So we can combine all that together in a big mishmash idea. So that may be the future. But I need someone who will help me to find the application for the materials that I'm synthesizing, because I cannot do it alone. I have no expertise in all the fields of science. So I need someone who will see my results and think, okay, that's interesting. That may be useful for me. So if you know anyone and you would like to cooperate, I'm open. I would like to thank Rongdeng and UNSW for inviting me here so I can be back after 3 years and tell you all about my research. I also want to thank the Gdansk University of Technology and the Research University Excellence Initiative. They were the founders of my first arrival here and being able to stay here for 5 months and work with people at UNSW. And thank you all. This is my contact. I know that my name is hard to spell for you, so this is the QR code. If you like to scan it, it will direct you to my email, and you can contact me anytime you want. Thank you all.
Thank you, Anna. Excellent presentation, and we all love the energy. And we have about 20 minutes for questions. Do we have any questions from the audience? Okay. Wait a second. Do we need a microphone? Yeah. Oh, Ivan first.
Thank you very much. This is exciting to see when you're looking for something and you figure out that there's maybe something else. That's great to see. One thing that caught my attention was when you were doing the cadmium telluride study, and then you mentioned that there was a problem with cadmium, but then I always thought that cadmium telluride, you cannot dissociate it once it's formed. You need to go to beyond 1,000 degrees. So I was just curious because we are sold this idea that cadmium telluride is stable, but maybe you saw something different?
I saw some results that small amounts, but it can be washed with water. So if the modules are laying in a landfill and they are not covered and they are exposed to the elements, especially in the environment where it's winter, so you have freezing, refreezing, the glass can break, so then it can be exposed to water and can be washed from the modules a little bit. It's not a big amount, but still may cause a problem. And in Europe, there is this law that waste photovoltaics are the hazardous waste, so because it contains cadmium. So we have to deal with that.
Welcome back, Anna. Love to see you again, and thanks for continuing the partnership with Ron. It's great. I guess since we last met, I've sort of got a lot more focused on the glass aspect, which is such a big fraction of the amount of waste, although not a very high value component. The processes that you're looking at, or your separation of the modules, what state is the glass ending up in your process?
We are looking for the techniques of delamination that will not break glass to very fine pieces. Of course, we find out that during thermal decomposition, the size of the fragments influence the emissions and what kind of emissions we get. And with grind and powdered modules, we don't have as much high volatile organic compounds. There are the simpler versions and the higher amount of inorganic emissions. But yes, I'm looking for the techniques to preserve the glass in the preferably intact state or in the large enough pieces. So also with the chemical delamination, we are looking for solvents that will not break the glass with the swelling, and we are trying to find out how to do it to don't disturb the glass in the way that it will not be qualified to the recycling process.
Do you have another question?
I don't want to dominate the conversation, but yeah. So it's just, I guess, the secondary related question was about the state of the cells. Also, are you?
With the delamination, I was only working with the thin film modules, so it wasn't impacting the cells. With the first generation of the silicon, I was working only with the cells. Yeah.
Anyone else have another question? Oh, Ben. Oh, just wait a second for the microphone.
Thank you. I wanted to ask if there's been any sort of success in recycling of polyolefins. I know you were talking about EVA and obviously that sort of being phased out. Is there any success in sort of extracting the polyolefin into a usable polyolefin?
I wasn't dealing with that. I had that idea, but I didn't find anyone to cooperate on that topic with yet.
I can make a quick comment. In general, POE is more difficult to deal with than EVA in general, but it really depends on your technique.
Yeah.
Yeah, a lot to explore. And
Yeah.
a question on Calvin? Just wait a second.
Thanks for the nice presentation. I have a question about the recycling policies in Europe and Australia. As you both ladies are expert in the recycling at different countries, do you see like the regulation policy or like the maturity of the recycling technologies in different countries? For example, do you need to have specific consideration of the policies you need to implement when you try to design the treatment process?
In Europe, the obligation is on the manufacturer. So in theory, that shouldn't be a problem. And in most cases, the bigger producers, when they are placed in Europe, they have their own treatment, and this is the secret. So no one knows how they are doing it. They don't want to disclaim any details about that. But when coming to the manufacturers from out of Europe, and this is the amount of modules that we are dealing mostly with these micro installations. They're imported, and there are companies that are collecting the modules and calling them the recycling facilities. But from what I've tried to find out, they are not doing any recycling process. They are just grinding modules. I don't know if that answers your question, but yeah.
Just have a question about your silver recovery work. So you mentioned you use a conductive polymer. So is there any requirement on the conductive polymer? For example, it has to be a very high conductivity, or as far as it's conductive that will work?
We only tried polyaniline and polypyrrole. If there is higher conductivity, it works better. And especially we had the polypyrrole that was synthesized as a powder and the polypyrrole that was synthesized electrochemically as a membrane. So the membrane works better.
The film even works better. Okay. And besides the silver nanoparticles you mentioned, is there any other things attached to it during your process? Or?
No, we didn't find anything else, only silver and silver compounds, so silver oxide or silver chloride on the surface of the conductive polymers.
Any other questions? Okay.
Yeah, you sort of hinted at this in your presentation, but is there anything we should know about the energy content for making the polymers, the electropolymers? Is it particularly high? Or?
Yeah, if it's made electrochemically, yeah, then it's high. If it's made in the powdered form, it's not that high because you mainly cool down the synthesis, so you can even recover the heat from the process, in theory, of course.
And after your process, would you hope to reuse that, or it's
the conductive polymer? I'm hoping that will be the product. So the composite, the conductive polymer with the silver nanoparticles will be the product ready to use in different applications.
Ivan?
Kind of a little bit of a follow-up on that, because I was thinking it's great that the silver, rather than going into landfill, is going to be reused, but it kind of defeats the purpose of the circular economy because we're making something else rather than just putting it back into the same system, right? And so is there any possibility that you could think of those polymers being used as part of the PV, a new PV design, rather than having to come up with something else to use it?
Yeah. I was finding in the literature that this type of polymers are being used in the PV manufacturing process. So it don't have to be the application outside of the PV realm. It can be in the PV manufacturing, but not the classical silicon PVs.
I have a question. So I'm always interested in reusing the silicon we recover from old panels back into making new solar silicon. And I've seen you've done some research. So I just want to ask your comment on whether that's a good approach. If not, what's the main problem?
It can be the good approach because we are skipping the steps of manufacturing the silicon itself. So it saves the energy, of course, and the carbon footprint. The main problem is how clean would be the silicon we obtain. So there are always some impurities. So it depends on which step of the silicon wafers manufacturing process we can put that recycled silicon into. So, yeah.
Nice. Any other questions? If not, let's thank the speaker again. Thank you, Anna. And